record, share, pow. Hope everybody's. I heard this morning on the radio. It's like, oh well, we're not doing that in run class. Come here. Um, it's like 12 degrees outside here, and it's like, oh, it's already 19 degrees in Sussex. It's like, oh my gosh, that sounds awful. It's too hot. I don't like hot. Yesterday we talked about concentration. That simple formula. Um, it's a kind of it's a relatively straightforward formula. You're going to be given enough information to find two of the three variables. The most complicated part is usually finding volume because it's in the denominator, but you guys are all wonderfully intelligent people. You can rearrange. Concentration is moles divided by volume in liters. You have to make sure there's liters. Solutions. How many moles of stuff do you need? Well, that's a great concept, but really it's how many grams do you need to make da 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 a volume of a concentration. And that's like if I'm making something up for a lab or an activity or a demonstration, it's like, okay, I need a solution of what have I made? Iron 2 or iron 3 thiocyanate. Well, I need a zero point 0.1 mole per liter solution. Well, I'm only going to make 100 milliliters. So how many moles do I need? How many grams do I have to weigh out, etc. Um, and I said on these ones, I went through how many moles of sodium carbonate is there in a 10 liters of a 2 moles per liter solution? Well, concentration times volume, 2 times 10 is 20. 10 milliliters is only 0.0100 liters, so 0.02. 100 milliliters is 0.1 liter. That conversion, especially going through to chemistry 12, being able to do kind of the kilo to milli conversions because you do stuff in kilograms, grams, sometimes milligrams, but milliliters to liters, being able to do those conversions quickly is relatively important. I said we'll look at these. I think there's a couple of them. Those are some questions that I normally would assign. And then we'll look at concentration of ions in solution. 10.3 grams of sodium chloride are dissolved in a small amount of water and diluted to 250 milliliters. We have, whoops, we have a mass, we have a volume. So we can, we know the volume is 250 milliliters. We want to know the concentration because that's what it's asking for. So we need to figure out moles. Well, if we have mass, well, I can convert 1 mole, 35 and 22. I want to say it's 58.44. Yeah, of course. I do my mole conversion. I do my handy dandy calculator trick where I take the inverse of that, multiply by 10.3. 0.176 moles of NaCl. Well, now I know this is 0.176 moles. I can do that. Find my calculator, 0.176 divided by 0.250, 0.704 moles per liter. So, like, the first sets of calculations, that's as complicated as it can get. Um, that type of question. Oh, I guess those are down below. Sorry, my bad. Salt water contains 28 grams. Convert grams to moles and divide by 1. Convert grams to moles and divide by 1. Convert grams to moles and divide by zero point 0.4. What mass is needed? Find moles, convert to grams. Well, that you need to convert grams. That's a find a volume. Find a volume. How many grams are needed to find moles? Like that. Like the questions are not meant to be tricky. How many grams of sugar are needed to make a 0.125 milliliters of a half molar solution of glucose? So how many grams means we're going to need moles first. Molar volume is divide by 1,000. Moles is concentration times volume. 0.50 molar. Multiply those out. 0.0625. And this is of, when you're doing the C equals N over V, what it is isn't super important, but when you get into doing your mole conversion, C6H12O6, 6 times 12.01 plus times 0.0625 is, there's only two significant figures because of that. 11 grams of glucose or fructose. So those are kind of the basic ones. The complicated concentration questions, you have a mole conversion tacked on to using that C equals N over V formula. So it's not, hopefully not all that out of the realm. Oh, still don't know why that pops up. So if you want to try, I'm going the wrong way again. Some of these, I did the answers to those three this morning. I guess technically four, because we could do that. I'll do a couple more answers. Holy smokes. But it's trying a couple. Concentration of ions in solution. So this links our dissociation reactions from equations in terms of solubility with net ionic equations and concentration. So if we have a strong acid or soluble salt, when we throw them into water, it splits up into whatever ions are there. If I know what the concentration of, like we don't list on the bottle the concentration of each ion, we don't list the concentration of everything. Well, we use what we put in. If I take however many grams of aluminum sulfate, which is a solid, dissolve it in water, and I calculate the concentration of this whole thing, I can use math and logic to figure out the concentration of the ions. Just quickly write the dissociation equations. So HCl dissociates into, H plus. Barium hydroxide is soluble, so we get barium 2 plus aqueous and 2 hydroxide ions. That's a really big bracket. Aluminum sulfate. Whoa, 2 aluminum 3 plus ions plus 3 sulfate 2 minus ions. Sulfuric acid. This is one. You get more or less 2 H plus ions, and whoever teaches you Chemistry 12 will explain why I say more or less, but effectively it's 2. So dissociation equations, we've talked about them for a while. We use in chemistry these square brackets to represent concentration, so we don't have to write different things out. So if I want to know if I'm talking about the concentration of the H plus ion, I write it in square brackets. If I want to know the concentration of the whole thing, you'll see equals 2.3 molar or something like that. It's just one of these little shorthand things. And I mean, I get lazy. I'm sorry. Shoot. Technically, we need those in there. So if I know the concentration, if I take, well, HCl is a gas, but if I take 2 moles of this and dissolve it in a liter, I would have 2 moles per liter of that. There's one of these begets one of those. So 2 moles per liter, the concentration here would be 2 moles per liter. Because if I throw that in a liter, I get 2 moles of HCl. Well, each HCl splits up, so I can get, it's a stoichiometric thing. Stoichiometric ratio determine the concentration of specific, of the ions for specific things. So I've got nitric acid goes to H plus aqueous plus nitrate aqueous. If the concentration of the whole thing is 1.35, I get one of each. The concentration of H plus is going to be 1.35 moles per liter. I just need to rewrite that with the aqueous sign. The concentration of nitrate ion is also going to be, if I put 1 mole of nitric acid in, I get 1 of each. If I put 1.2, I get 1.2. Where this gets a little bit fun, strontium hydroxide goes to strontium 2 plus aqueous, but for every one of those you throw into a pail of water, you get 2 moles or 2 equivalents of hydroxide. So if the concentration of strontium hydroxide, the whole thing, there's a 1 there, there's a 1 here. Whoops. If that concentration is 2.8, this concentration is 2.8. But the hydroxide ion concentration, whoop, every once in a while I'll do that by accident. If I put 1 strontium hydroxide, I get 2 hydroxides. If I put 2, we get 4. So if there's 2.8 of this, we get 5.6 moles per liter because we get twice as much hydroxide. iron 1 sulfate. Interesting. We get 2 of those. If this concentration is 0.185, there's a 1, there's a 1. I'm going to do this one first. This one would be 0.185 moles per liter. This one, because we get 2 of them for every one of them, 18 and 18 are 36, 37. Point 0.37 moles per liter. So it's just a stoichiometric thing. You don't have to show any calculations. 2H plus. The concentration of hydrogen ions here would be 2 times 0.37. 36 and 36 is 72, 0.074 moles per liter. Because it's 1 and a 1, 0.037 moles per liter. So what I would, those are, number 5 is up here is just, I don't even know why it's called number 5. Sodium sulfide. What are the concentrations you need to do those two things? Or you would. This is a nifty question. If a liter of 0.1 moles per liter sodium nitrate and a liter of, oh, that was loud. I don't know if you guys hear those or not, of magnesium nitrate are mixed, what is the concentration of sodium, magnesium, and nitrate ions? Um, this gets to be kind of entertaining because sodium nitrate will dissolve and go to sodium ions. Magnesium nitrate, because magnesium is +2, after we go through this. So the original concentration of this is 0.10 moles per liter. So the concentration of sodium is 0.10 moles per liter. The concentration of nitrate from that solution, 0.1 moles per liter. 0.2 mole per liter magnesium nitrate. That would be there. This is going to be doubled, 0.4. Now this kind of leads into the next topic, which is dilutions. If I take a liter of one and a liter of the other and mix them together, my final volume is, this is where in class someone would shout, 2 moles per, 2, whoa, whoa, whoa. Wrong letter, off by 1. 2 liters. So if I now have 2 liters of solution, what do we have to do to all of our concentrations? cut them in half. So when we do that dilution, this is 0.050 moles per liter. Because concentration depends on the volume that's there. So my concentration of sodium ions is my concentration of magnesium is now my concentration of nitrate. Nothing in this mixture is reacting. So this is adding two different things, and I'm being lazy and forgot my aqueous signs, is the sum of those two 0.25. That's a normally would be a thinking type question, but um, I was going to explain that. On Monday, we'll talk about dilutions, which is a formula. M1V1 equals M2V2 or C1 and a couple of questions. Then we need to do some stoichiometry. And then we'll see where we kind of go from there. But that's today. Does anybody have any questions? If not, well, I'll see the three of you in 35 minutes. It's better than waiting until 2 o'clock. Bye.